Okay, well, yep, thank you very much for having me up. It's a pleasure to be here. I'm going to be taking another look at some of the work that we do, a little bit different from what Jennifer's presented, and if I had another 20 minutes, I'd probably hit on several more of these expectations. But I'll try to cover them the best I can with what I have in this presentation, and then I'm here all day. We can follow up on some of the other issues that I don't get to cover in this presentation. I'm going to be focusing on NOAA's land cover and habitat mapping program. I'll do a quick look at our regional and national mapping efforts, and then do a fairly shallow dive into some of the high resolution work that we're doing now, and talk about applications of those data sets. So quick background on who we are. The Office for Coastal Management came together when the Coastal Services Center, which was primarily a geospatial shop, merged with the Office of Ocean and Coastal Resource Management, which really does our coastal zone management. They track mandates, they work with the state agencies, they track coral reef conservation activities. These two organizations came together, and now we're the Office for Coastal Management, and so under our umbrella we cover quite a bit. We still do all the coastal zone management work, coral reef conservation, and now we have a new tool, platform called the Digital Coast, which I'll talk about a little bit. And this is our platform for making data and tools and trainings available to everybody, to the public. And that's really kind of one of the focal points for our work in the coastal realm. And then the final slide, or the final graphic there, is talking about the National Estuarine Research Reserves, one of our keystone partners. And there are several of these around the country that focus on doing coastal research, and we've partnered with them. And I'm going to be highlighting a project in this presentation that we're doing with one of them in the Northeast. So the Coastal Change Analysis Program is one of our larger mapping programs. This is national in scope. We basically do repeat land cover characterizations for the entire country. We focus on the coastal zone, and then through our federal partners, the USGS, Forest Service, EPA, and others, we are able to cover the entire country. But this particular program and our contributions to it really focus on that coastal zone, and I'll show you a map of what that means for us. We really focus on the intertidal areas, wetlands, and then those adjacent uplands. These are those critical zones that we're most concerned about tracking. These are the areas that are experiencing the most rapid development and stress from climate change and coastal storms. So we're very concerned about these areas. And we do a lot of work developing additional tools that leverage these data so we can understand some of the processes, those linkages between all of the stressors that I mentioned and the impacts that we're seeing on land. Our classification scheme at the national scale is presented here. We break it out, a variety of categories between the developed, agricultural, range, forest, barren land, water, quite a bit of detail in wetlands. And then when we get into the high resolution product, the only distinction really is that we've been able to look at the developed classes and actually determine whether or not it's an impervious surface or not. So the developed classes here for our moderate resolution product are based on 30-meter pixels, and so we can't really determine, is a specific location within a 30-meter pixel impervious. So with the 1-meter or the 2-meter product that we're developing, we can actually determine whether or not that's an impervious surface. So it's the only distinction between our moderate resolution and high resolution land cover product. So a quick look at our regional product line. This is a graphic showing our mapping extent in blue. So you can see our definition of coastal zone is fairly loose because we've included all of Vermont and some of the other states. But essentially we are looking at those estuarine drainage areas and coastal watersheds, and then depending on kind of where the line falls in our agreements with national or other federal partners, we have included additional areas. Historically, this has been based on Landsat Imagery, which is a 30-meter resolution product. And we've been doing these updates every 5 years. In some cases, we've gone back in time as well, so we can understand back to the 40s, for instance, what was occurring in the landscape. We do this mapping primarily through change detection at this time. So we can do some change detection with different dates of imagery, and then just do a quick update to a prior product. And we're also doing this back in time as well to refine and update some of the older products that were developed using older technologies. And then from the information that we're collecting with these snapshots every 5 years, we can start talking a little bit about the trends that we're seeing throughout the country. And this is a very high level national statistic where 65,000 square miles have changed between 1996 and 2010. And then we can break that down by the actual land cover classes, where we're seeing great loss of forest and quite an increase in shrub. And that's primarily due to the forest industry and just how forests are being harvested, and then there's regrowth as we're seeing the shrub. There's also a net loss of wetlands, and again, we're talking about coastal wetlands in this particular summary. And it was interesting, the only area where we actually saw a net increase in wetlands was the Great Lakes, and that was because of the lake levels dropping and exposing more habitat, and so we saw a net increase there. So anyhow, that's kind of what we're able to extract from our national land cover data. We've got a whole set of tools and viewers and atlases and summary tools that we've developed that leverage these data, and they're fed up into all sorts of different projects, but I'm not going to dwell on that. You can get this information through the Digital Coast. We've got regional change reports that summarize all of this information. You can see how we are looking at the information. So those are available, and again, I'm not going to dive into that too deeply because I want to focus today on the high resolution land cover and change mapping efforts that we've starting about 7 years ago, really started to dive into. We, at this point, have been doing high-res mapping at just a few key areas. And again, this is because it's expensive and it has been driven by partner need. That's how we identify our projects. And these are hot spots. So I mentioned the National Estuarine Research Reserve system. That network of organizations and partners really have been driving a lot of the science as it relates to understanding how marshes are changing over time. So we are focusing a lot of our high-res mapping efforts in those areas, for instance, but other areas as well. We have to kind of select these areas based on data availability as well. Not all the areas have the high resolution imagery or the elevation data that we need to drive our mapping process. And we also, because it is expensive, we've been doing this through cost share with the reserves or the state agencies or other federal agencies who are interested in working with us. And one of the key points here is that our mapping uses object-based classification technique, and I'll talk a little bit about that, and that's kind of how we drive this process. So a quick comparison between the two products. I've talked about our moderate resolution regional product and then the high resolution product. This is an example from Pearl Harbor in Hawaii. The moderate resolution, the Landsat-based image here on the left, and then on the right you can see our high resolution product. That was based on some QuickBird imagery, so 2.4 meters. I should mention our high-resolution products have ranged between 1 and 3 meters on average. Kind of depends on the sensors we've been using and also the scale of the project. So that's a quick snapshot of how the two products can compare. Why are we going with an object-based image analysis process? Well, high-resolution imagery, when you're talking about 3-inch or 6-inch imagery, there's a lot of information. There's a lot of noise when you kind of do the spectral analysis. There's a lot of confusion there. So by running some algorithms, and on the right, if you notice, I'm going to advance the graphic here, you can see we've cut it up into polygons. And the software we're using is called eCognition that allows us to go through and based on contextual information and spectral information, we can actually develop those polygons and then essentially classify each polygon based on the statistics we're able to extract from those polygons. And we can extract information from the imagery as well as other information from LiDAR, and I'll show you a little bit more about that. So again, another example of what this looks like. There's the raw imagery on the left. It's a high-resolution orthophoto, and on the right we've developed some image segments, those polygons. And then through some decision trees and classification processes, we're able to fill those in. It's essentially paint by number. Once we understand the actual parameters and we've developed our metrics, we can then start to classify. So on the left we're looking at a salt marsh with open water, exposed mudflat, bare land, pans and pools, and then some upland classes. And this was an early example. We've taken it from this stage, and now we're starting to look at species level classifications. So this was kind of an early generation of our high-res mapping. So this brings us back to the National Estuarine Research Reserves. And in particular, we're going to take a quick look at a project with the Narragansett Bay Reserve down in Rhode Island. This was an effort where the entire state of Rhode Island actually was very interested in understanding more about their salt marshes. And the reserve itself, being a site for research and a focus on marshes, they were very interested in partnering with us and providing a lot of the field support that we needed. So with funding from the state, and then through our efforts to provide technical assistance and do a lot of the heavy lifting, the reserve provided a lot of field support and then map reviews. And the partnership came together, and we're actually in the process right now of proceeding towards a final product. The idea was to understand the health and resilience of Rhode Island's salt marshes. So we're seeing sea level rise in most areas around the country. It's really affecting marshes. They're very concerned about the marsh sparrow. The marshes down there are, very, very key habitats. There's a loss of high marsh, which again is one of those critical areas. And through prior research, looking at LiDAR data and other data sources, we've understood there's general lack or depletion of elevation capital in these areas, with sea level rise kind of exacerbating that problem. So we wanted to understand and help them understand where the marshes are currently, how they are progressing. Are they declining in health? Are they kind of holding steady? Or are they improving? And then I'll talk a little bit about how they might go about prioritizing areas for conservation and restoration and possible climate mitigation. And through this process, we also wanted to develop something that was repeatable and transferable, because the Narragansett Bay Reserve is not the only reserve we're going to be working with. We want to be able to roll this out to others. In fact, we have developed agreements with the other 3 reserves in the Northeast to do this exact same sort of project as the data become available.